In this video, we shall look at homogeneous differential equations. An equation that can be reduced to the form given below. Like that. Is called a homogeneous differential equation. It can be solved by means of substitution. And this is the following substitution that one can use. Y over x equals to, let's say, v. That means y equals x times v. So the derivative of y with respect to x using the product rule will simply become v plus x times dv dx. Now we can use this to express this equation fully in terms of v, and that would become v plus x dv dx equals function of v. The variables are now separable, and we obtain dv over fv minus v equals dx over x, which can be integrated, and the right hand side will simply give you the natural log of x plus a constant, let's call it c. And finally, after the integral on the left has been evaluated, the required solution is obtained by replacing v by y over x. Now let's look at a few specific examples. Example 1. Let's look at the following differential equation. The right hand side can simply be reduced in the following form: x over y plus y over x. If you let y over x to be v, the left hand side is just 1 over v plus v, and the equation has been reduced into a homogeneous form. As we have seen before, from this substitution, we know that dy dx is just v plus x dv dx. Now let's substitute this derivative into the left hand side of that equation, and that's going to give you v plus x dv dx equals, now the right hand side is 1 over v plus v. This v goes away, and the variables can be separated. v dv equals dx over x. And we can readily integrate this line, which will give you half v squared equals natural log of x plus an integration constant, let's call it a. Substituting y over x for v, you get y over x squared equals 2 natural log of x plus 2 times a. Rearranging, we get y squared equals 2x squared natural log of x plus a. And that is the general solution to this differential equation. Problem 2. We can rewrite the above differential equation slightly in the following form: dy dx tangent y over x equals y over x. And by rearranging the term a little, we will get dy dx equals tangent y over x plus y over x. And this is in the form of homogeneous differential equation. Now let's use the following substitution: y over x equals to v. So the left hand side will simply become x dv dx plus v, which is worked out from this transformation equation. The right hand side in terms of v is simple. It is just tangent v plus v. So this v will get cancelled. Rearranging and separating the variable, we get dv over tangent v equals dx over x, and this can be readily integrated. The left hand side is just cosine v over sine v dv, and the right hand side will give you just natural log of x plus an integration constant, let's call it natural log of a. The integrand of the left-hand side integral, the denominator is sine, the numerator is cosine. So the numerator is derivative of the denominator with respect to v. So if you make a substitution, let's say w to be sine v, then dw is cosine v dv. So that integral will simply become the integral of dw over w, which is just natural log of w. Since w is sine v, it is just natural log of sine of v. So there we have it. Natural log sine of v equals natural log of x plus natural log of a. That means sine of v is just x times a. Now since v is y over x, you can rewrite that sine y over x equals ax. So that means you can express y in terms of x, and that's going to be x times inverse sine ax. And this is the general solution to this differential equation. Problem 3. To reduce this equation in the form of homogeneous differential equation, we divide up and down by x squared. So 2xy over x squared over x squared minus y squared over x squared. In the numerator, that x will cancel that x, and you'll get 2y over x over 1 minus y over x squared. If you assume or make the following substitution, y equals to x equals to v, then this equation can be rewritten in terms of v in the following manner. It is x dv dx plus v equals, the right hand side is just 2v over 1 minus v squared. This term is that one right there in terms of v. Now we can rewrite this line in a following manner. By bringing this v to that side, it's going to be 2v over 1 minus v squared minus v. And by equating or making the denominator common, we get v plus v cubed over 1 minus v squared. And we see that from this side and that side, the variables can be separated into following form. 1 minus v squared over v plus v cubed dv equals dx over x. And this can be readily integrated. Let's look at the left-hand side integral using the method of partial fraction. 1 over v squared over v plus v cubed can be rewritten in the following form. It is essentially 1 over v minus 2v over v squared plus 1. So putting this result in here, the left-hand side integral will become the integral of 1 over v dv minus the integral of 2v over v squared plus 1 dv. And the right-hand side is just natural log of x plus an integration constant. You can call it natural log of b. The left-hand side integrals can be easily evaluated. The first integral is natural log of v. The second integral is just the natural log of the denominator, which is v squared plus 1. As you can see again, the numerator is the derivative of denominator with respect to v. So the answer is just the natural log of the denominator itself. So let's rewrite this on top. Natural log of v minus natural log of v squared plus 1. We can combine the left-hand side logarithm into one logarithm, natural log of v over v squared plus 1. Likewise, the right-hand side is the natural log of x times b, which means v over v squared plus 1 equals x times b. Substituting back v as y over x, we get y over x equals xb y squared over x squared plus 1. And that means you have y equals bx squared y squared over x squared plus 1, which can then be reduced in the following form. Y is just by squared plus bx squared. And this is the general solution to this differential equation. Please like, share, and subscribe if you find this video useful. It will help the channel grow so that more educational videos can be posted for the benefit of many. As always, thanks for watching.